Okay folks, so in the last class we more or less completed our understanding of the multiple linear regression model. Right? We said that how we know, for example, we now know how to take a t-test, we now know how to take an f-test, we know what's an r-square and all those kinds of things. Okay? Today, I'm going to talk to you about an important issue. The critical issue of where there might be a problem with a linear regression model. Okay? That is the whole approach to simultaneous equations models. Okay? Today what we'll learn is the basics of simultaneous regression models and the idea of an instrumental variables estimator. Okay? The idea of an instrumental variable estimator. Is this clear? Okay. So what is a simultaneous equation system? Think of, all of you have studied the consumption, the Keynesian consumption expenditure, the consumption in a function. Alright? What is the Keynesian consumption function? A plus byt plus, of course, in a linear regression context, et. C is equal to A plus byt plus et. So consumption is A plus, everybody knows this. This is the marginal propensity to consume and so on. We also have yt as equal to ct plus it, where ct is the consumption expenditure, it is the investment expenditure. Right? Now you see there are two things here. The variables ct and yt are in a sense different from it. What is the difference between the variable ct, yt and the variable it? The values of both ct and yt are determined within these equations. So if you know what is it, right? Okay, sure? If you can figure out what is yt. So yt will be determined if you know ct and it. Ct will be determined if you know yt. But it is given exogenously. The value of it is not determined from within the system. The values of ct and yt are determined from within the system. The value of it is determined from outside the system. It is called an exogenous variable, whereas ct and yt are called endogenous variables. So ct and yt are endogenous variables, whereas it is an exogenous variable. Okay. Now, we will write this system in the form of what is called, this is a structural system of equations. This system of equations is called the structural system of equations. We can rewrite this into what is called a reduced form. What's a reduced form? A reduced form occurs when all the endogenous variables are on the left hand side and all the exogenous variables are on the right hand side. Is this at the moment a reduced form? No, because there is one endogenous variable on the left hand side. There is one endogenous variable yt on the left hand side here, and there is another endogenous variable ct on the left hand side here. So this is not a reduced form system. In a reduced form system, you will have ct and yt on the left hand side, alright, but on the right hand side you will only have, so here you will only have, sorry, on the left hand side you will only have it. On the right hand side you will have ct and yt. So all the endogenous variables written purely as functions of exogenous variables is called a reduced form system. It's called a reduced form system. So how do I write this in the reduced form? Let me first start writing this as, so I have from here, so let me look at the first equation, ct, right? This can be written as yeah? Why? I have substituted for yt. So this becomes a plus b ct plus BIT plus ET, right? BIT plus ET. Okay. This is CT. So we have, I can take this on this side. Yeah? Okay? Or what I can write from here is, CT okay. So this is the reduced form for CT. This is the reduced form for CT, right? The reduced form for CT. Similarly, if I have to derive the reduced form for YT, I know YT yeah? How do I get YT is equal to A plus BYT plus ET plus IT? Because this part is nothing but CT and YT CT plus IT, right? You know, income is consumption plus investment, right? So what do you get for YT? For YT, you would get YT minus BYT is A, or YT is equal to A upon 1 minus B yeah, right? Now you see, so this is a reduced form for YT, this is a reduced form for CT, right? So this equation for CT and this equation for YT are called reduced form equations. Why the reduced form equations? Because YT and CT, the endogenous variables, are on the left hand side of the system of equations. On the right hand side, you only have the exogenous variables ET and the exogenous variables IT and the exogenous disturbance ET. Is this concept very clear? The difference between a structural form and a reduced form. Can anybody tell me what is the difference between a structural form of equations and a reduced form of equations? Yeah? Yeah. So in the reduced form, you'll have the endogenous variables written purely as a functions of exogenous variables. Whereas in a structural form, that might not be true. That will not be true in general. Right? Now, the reduced form is particularly illustrative. Because what does the reduced form tell you? The reduced form tells you that YT is correlated with ET. Right? You see why YT is correlated with ET? Sure? Because if ET changes, YT will change. Which means that if you try to estimate this regression, you will not get unbiased or inconsistent results because ET and YT are correlated. You see the point? ET and YT are correlated. Okay? Right? ET and YT are correlated. How do you see that? You don't see that from the structural form, but it becomes clear once you look at the reduced form. So the point is, you cannot really estimate the structural form equation by itself. You cannot estimate the structural form equation by itself because you will not get unbiased estimates. This is to be called the simultaneity bias. The fact that the OLS estimator for beta hat will be biased is called the simultaneity bias. Right? Okay, the OLS estimator for beta hat. That is, if you calculate beta hat, which is summation CT minus C bar YT minus Y bar, this will be the formula for beta hat. Right? Beta hat, I will write OLS, and alpha hat OLS will be C bar. Yeah, you see why alpha hat OLS and beta hat OLS will be this? Sure? Right? So the point is that both these estimates will not be unbiased, because we know that if Y and E are correlated, then the OLS estimators are neither unbiased nor are they consistent. Okay? This is used to be called simultaneity bias. Increasingly we call it the endogeneity bias. Why endogeneity bias? Because actually the explanatory variable yt here is an endogenous variable. It's not an exogenous variable in this regression. CT depends upon yt, alright, but yt also depends upon CT. So if one of the explanatory variables is endogenous to the system, then you do not get unbiased estimates, unbiased or consistent estimates using OLS. This problem is called the you can call it simultaneity bias, or you can call it the endogeneity bias. I prefer the term endogeneity bias. In general, we will say there is endogeneity if the error terms and the explanatory variables are correlated. Error terms and the explanatory variables are correlated. Is this clear to everybody? Right? I'll give you another example. Yeah, this is clear? Okay? Sure? Okay. To take another example of this, yeah, think of a demand equation. What does demand depend upon? Price. Okay, so it is we'll expect B to be negative. We'd expect B to be negative, right? Quantity demanded is A plus B PT plus E1T, where E1T is the usual error term. You can also have a supply equation. Yeah, you have a supply equation. So QS is equal to C plus dPT plus E to T, where left hand side is the quantity demanded and is the quantity supplied. But when you go to the market and try to look at the quantity sold, then neither purely quantities demanded nor quantities supplied, but the points at which the demand curves and the supply curves intersect. So they are the points which you see in the market are the points at which the quantity demanded and the quantity supplied are the same, the points at which the demand curve and the supply curve intersect each other. You don't observe a separate quantity supplied and a separate quantity demanded, right? What you actually observe in the market is the quantity bought and sold, and the quantity bought and sold is a quantity where the demand and supply are equal, right? So what you see is a QT which satisfies the condition QSD is equal to QDT, right? Now, let me try to write this in the form of a, so basically here what are the endogenous variables? QT and QD are all endogenous variables. The price is also an endogenous variable because price is determined from within the system, it's not given to you exogenously. Price is determined within the system, it's not given to you exogenously. So let me write this system as a system of, let me try to write this in the reduced form. Okay, right. So if I try to do that, first let me write this here. So I have right? From which what do I get? I get A plus B PT plus E1T is equal to, yeah, right? From which I have so what I have from this is yeah, or I have A so or let me write it like this. I have BPT minus DPT is C minus A, yeah, plus E2T minus E1T, okay, or you would get yeah, or you would have so that would be PT, right? And what would then QT be? So if I, for example, put QT in this axis, right? If I substitute